In the last video, we looked at supervised learning. In this video, we're going to look at the other two types of learning, unsupervised, shown here, and reinforcement learning, shown here. Reinforcement learning involves a supervisor that can only tell the robot whether it is right or wrong. Unsupervised learning does not involve a supervisor at all. There are some cases in which we do not have any labeled data to give to our robot that it can learn from. This happens, for example, in cases where we want our robot to learn to perform some operation that we ourselves do not know how to do. We want to be able to give the robot an example of how to do it and have the robot learn to do it from the example, even though we can't give it specific rules or data that is labeled that it can use to learn. The way we're going to do this in unsupervised learning is by using a method that's called k-means clustering. This is a method where we can cluster the data into reasonable grouping. Here's an example of how k-means clustering works. Let's suppose that we have data that comes from different animals, but we don't know which animal each data point came from. We also may or may not know how many different kinds of animals are represented in the data. Can we simply give this data to the robot and have the robot discover groupings in the data? Here's an approach that we can use to have our robot discover reasonable groupings in the data. First, we're going to guess locations for the centers of these clusters. Notice that I've drawn 3 data points on this feature plot in red, green, and blue. These data points represent the centers of clusters that we are guessing. We don't know their location. We simply guess locations. All of the other data points are colored black. That's because we don't know which group each of those data points belongs to, so we don't know which label to give each data point. Once we've guessed centers for these 3 clusters, what we do is we take each data point, each of the black data points that we don't know which group they belong to, and we simply assign it a label according to which of these guessed centers is closest to it. We know that when we do this for the first time, we'll make lots of mistakes. We'll classify lots of horses as dogs and lots of dogs as rabbits and so forth, but that's okay. We'll get better at our classification over time, and here's how that works. Once we've assigned every data point to the cluster center that is closest to it, we move the cluster center, our guess at the cluster center, to be the actual center of all of the data points that we've assigned to that cluster. So here we've moved the red, green, and blue data points from their original guess locations shown here to the locations that are the center of each of these data points groupings. Now we're going to repeat the operation. With our centers in their new locations, we're going to reassign all of the black, unknown data points to the cluster center that is now closest to it. Notice that many of the points have been reassigned. Here's what the data points looked like before. Now, when we reassign the points to the new center that is now closest to it, we get different groupings. We then repeat the process. The center is once again moved to be the actual center of the data points that we have grouped together. We'll keep repeating this process until the cluster center locations don't change anymore. Each time we go through the loop, the cluster centers stay the same. After our training is finished, we have center locations for each cluster that do a good job of classifying all of our training data. That is, these black points that had an unknown label, but that we used to find the centers of the clusters. We can then get rid of our training data and look at our testing data. A new point that we've never seen before from the testing set is assign the class of the center that is closest to it. Here are some of the benefits and drawbacks of the k-means clustering method. The big benefit is that you don't have to have labeled training data, so you can use this method to teach the robot things that you, the robot builder, don't know yourself. But there are also a couple of drawbacks. First of all, the data must actually be organized in some kind of clusters. Otherwise, the robot will imagine associations where there are none. And secondly, if you don't know how many clusters to look for and you guess the wrong number, you can end up doing a poor job of organizing the data into clusters. You can overcome this drawback partially by testing different numbers of clusters until you get a good mapping of the data to the class and keeping that number. But in general, you either have to know how many clusters you're looking for or you have to figure it out somehow within your process. Let's now take a look at a method that is partially between supervised and unsupervised learning. This is a method called utility maximization, and it's an example of a learning category that's called reinforcement learning. In this approach, what we're going to do is initialize some starting point. Then, the robot is going to guess an action to take. After the robot takes that action, it's going to check to see how much reward resulted from that action. Then, the robot has to decide whether to repeat the action that has given the robot the biggest reward in the past, or try a new action to see if it can get a bigger reward with a new action. This trade-off between deciding whether to pick the action that in the past gave it the best reward or trying a new action that might give it a bigger reward is called the exploitation-exploration trade-off. Here's an example of how this method works applied to the example problem that we've been working with throughout these videos. Here we have two sets of categories from our training data. Rabbits, shown here colored blue, and dogs, shown here colored red. What we do is we first guess a line that might separate the data. We will then check to see how correct the line is. Correct classifications are a reward, and incorrect classifications are a punishment. Remember that in this reinforcement learning method, we have a supervisor that is able to tell the robot whether it is right or wrong with each classification, but cannot tell the robot what the correct answer is in the case where it gets it wrong. Next, the robot will move the line. It can either shift it left or right, or it can change the angle of the line. The supervisor then once again tells the robot in what cases it made a correct classification and in which cases the classification was incorrect. The robot receives a reward for each correct classification and a punishment for each incorrect classification. Actions that give the robot a greater reward are more likely to be repeated, while actions that give a punishment are less likely to be repeated. Over time, this process will result in the robot learning to classify the two different classes of data correctly. Machine learning in general has a number of common applications. Some of these applications we've already looked at in this class, including machine vision and machine audition. But there are other applications as well, such as handwriting recognition or voice recognition. You can also use methods like this for more complex applications, such as learning behaviors.